Hello grade 12s, how are you today? This is Tutor Kamala. Yes, you are once again welcome to our part 2. This is video 2 for question 1, paper 1 mathematics. My name is Patrick Kamala once again. I'm a tutor and educator for mathematics and physical sciences, grades 10 to 12. So this video is meant for those learners who are preparing for their end of year examination paper 1, whether it is November or May, June. So now it's also meant for those learners who want to understand mathematics from the basics. That means if you missed out something in your class, please, you're more than welcome. Just get your calculator out and a pen and a paper and practice as we teach here. Thank you. Now it's a continuation of video 1, question 1. Today we're looking at the exponents and the SURDS. So what are exponents? What are exponents, teacher? Now exponents occur when multiplying or dividing expressions or bases or variables numerous times by similar expressions or bases or variables. We are saying that exponents, they occur when multiplying or dividing expressions. Okay. Yes, hello. We are saying that exponents occur when multiplying or dividing expressions, bases, variables, numerous times by similar expressions, bases, or variables. Okay. What about SURDS? A SURD is a mathematical terminology for irrational roots. So when you hear the word SURD, we mean a mathematical terminology for irrational roots. And when numbers are left in a root form as opposed to rounding off to decimal places, okay, that's when we get our SURDS. Okay, now let us look at some helpful hints for equations or expressions. Now what we do in this topic, we express larger numbers in exponential form by prime factorizing. We're going to look at examples shortly by doing what? By prime factorizing. That means getting the factors, and then from there remove a common factor if two unlike terms are separated by a plus or a minus sign. We are saying that you do what? You remove a common factor if two unlike terms are separated by a plus or a minus sign. Then also ensure that your SURDS are always expressed in their simplest form. Ensure that your SURDS are expressed in their what? Simplest form. And then express SURDS in exponential form for simplification. Yes, you express them in exponential form for simplification. We're going to look at examples as well. And then take note of the following. This is a common error. When solving for an unknown base with a fraction as an exponent is to multiply the exponents on both sides by unknown exponents inverse so that the exponent will be 1. That's very wrong. However, if you express these fractions as SURDS, you will notice the following. Okay, notice the following. An even power will always produce a positive and negative solution. For example, x power 4 over 3 equals to 3. We're going to have it as the cube root of x power 4 equals to 3. And then we get x power 4 equals to 3 power 3, which is 27, which gives us the fourth root of 27, which is a plus or minus. And then a negative number inside an even root cannot solve for a real solution. So when you get something like this, please don't continue. You stop there because there is no real solution. Then an unknown inside or an even root cannot solve for a negative solution either. So when you have x power 3 over 4 equals negative 2, it means you have no real solution as well. Why not? Let us now start by adding and subtracting like terms. Okay, now like terms are the terms in an equation or expression that have identical variables and exponents. We're saying that like terms, they are terms in an equation all expressions that have identical variables and exponents. Okay, so to add or subtract these terms, what do? We simply deal with their coefficients. And don't forget that exponents never change when the operator is a plus or minus. So when you are adding or subtracting exponents, the power does not change. Only changes when we are either multiplying or dividing. Okay, but when we are simply adding or subtracting, we have no change. Now take an example here. If we have 3x squared y power 4 minus 5x power 3y then plus 2x squared y power 4 then plus x power 3y. Now look at the like terms here. This is x squared y power 4. Does it have a like term? Let's check. So you look for another x squared y power 4. It is here. So this is a like term to the other one. Okay, and then the other one, which is not like that one, the one for this is now x cubed y. So this one is x cubed y. Does it have a like term? Let's check. This is x cubed y. So now I deal with the like terms. Okay, you see this is positive 3, this is positive 2. So because they are the same variables, these are called like terms. So what is 3 plus 2? I get 5, which is 5x squared y power 4. And then what is minus 5 plus 1? Because there is 1 here. There is 1 here. Minus 5 plus 1 gives me minus 4. So that's how I get my answer as to be 5x squared y power 4 minus 4x cubed y. Hope we are together. You see, that's how we identify and add and subtract like terms. Now it could also be in sides, like in this case, where I have 3 root 2 plus 5 root 3 minus 8 root 2 plus root 3. Okay, now in this case the like terms have the same root. In other words, this root 2, 3 root 2 is a like term to this other one with the root 2. So this is a like term to the other one, okay, because they have the same root. And then this other one, which has got root 3, that is 5 root 3, is also a like term to the other one, which is also 1 root 3. Okay, then now I can add or subtract. Check here. This is 3 root 2. I'm looking for another root 2. That is 8. So what is 3 minus 8? I get negative 5 root 2. And what is 5 root 3 plus 1 root 3? I get 6 root 3. So that's why my answer is going to be negative 5 root 2 plus 6 root 3. I hope we are together. If we are not, please pause the video and replay it, or you may come at our tuition center in Polokwane here, or 92 Kamala at Rostec College. I'm sure you understand much better. Okay, let us proceed. Now, again, to do with exponents and SURDS, we have what we call as the laws of exponents. Okay, now the laws of exponents only apply to multiplication, division, brackets, and the roots, never adding or subtracting. Okay, are we together? Let's look at these rows here. Algebraic notation here, then exponential notation, then exponential law. Let us see how they work out. Okay, now first of all, if I have 16 is the same as 2 times 2 times 2 times 2. That's algebraic notation. But in exponential notation, I count how many 2's are here. 1, 2, 3, 4. So it's going to become 2 to the power 4. Are we together? So when we multiply the same bases, we add the exponents. So it's like we have 2 to the power 1, power 1, power 1, power 1. So 1 plus 1 plus 1 plus 1 gives us 4. That's why it's going to be 2 to the power 4. Another illustration is 64 divided by 16. That's the algebraic notation, gives us 4. Now when I come here, I can write it as 2 to the power 6 for the 64 divided by 2 to the power 4 for the 16. And then in this case, you see, I must get 4 like you see it here. This is 2 squared, which is 4. But how do I get this 2 squared? This is square I get by subtracting the exponent, that is to say 6 minus 4. So then the exponential in operation is called what? We say that when we divide the same bases, we minus the exponents. That is always top minus bottom. Hope we are still together. Then another one is here. If I've got 4 to the power 3, which is the same as 64. Now in this particular case, I can write this 4 as 2 squared, but because of the power 3, now how do I get it? Now 64 is the same as 2 power 6. How do I get power 6 here? By multiplying, okay? By multiplying the 3 and the 2. So then the law says in this case that when we have exponents outside the brackets, we distribute or multiply them into the brackets. Are we together? And then another one here, I have 64 divided by 64 to give me 1. Now 64 is the same as 2 to the power 6, even down here 2 to the power 6. So because this must be 1, and if I subtract 6 minus 6, I'm going to get 0, meaning 2 to the power 0 should give me 1. So please note this. Any base, whether it is 5 or 10 or 100, but to the power of 0 is equal to 1. But don't forget that 0 to the power 0 is undefined, so don't be misled with that. Now another law here, this notation says here, the cube root of 64 equals to 4. Now 64 is the same as 2 to the power 6. Now cube root here, it is this one here which you see. But to get my answer as a 4, which is a 2 squared here, how do I get it? I do what? I follow the law. The law says that the power inside the root is divided by the size of the root. So the size of the root here is 3. What about the power inside the root? It is 6. So 6 divided by 3, I get 2. That's why I get this power 2 here. Hope we are still together. And then next here we have 4 times 9 to give us 36. But what is 4? In exponential form, it is 2 squared. What about 9? It is 3 squared. What about 36? It is 6 squared. Okay. So in other words, the law here says that if we have non-identical bases but identical exponents, we keep the exponents and multiply the bases. This same rule will also apply for division. Okay. So you see here the base is 2, here the base is 3. What about the exponent? Exponent is 2 and 2, but because it's the same exponent, I keep the exponent and multiply the base, that is 2 times 3, which gives me 6. I hope we are together. We're going to see us apply this in our factorization and the solving, okay? Now if I have root 2 times root 3, I get here what? I get root 6. The same thing happens. Now square root means to power a half. So because the power half is the same in either case, it is all to the power half. So I keep the exponent and multiply the base, which is 2 times 3 to get the 6 power half here. That's why it remains 6. And then here if I have root 2 times root 2, I'm going to have square root of 2 times 2, which gives me 4, that is going to be 2. In this case, don't forget that now because I'm multiplying, I have the same base, which is 2 to the power half times 2 to the power half. I'm going to keep the base and add the exponents. So it's going to be a half plus a half, which gives me to power 1. So I say that any square root multiplied by itself will equal the term inside the root. Hope we are together. Let us look at how to convert SURDS into exponential notation and vice versa. Now the power inside the root becomes the numerator and the size of the root becomes the denominator. Please note this. Many learners confuse this, but I don't want to confuse it from this very moment. Okay, we are saying that whenever we have the power inside, okay, inside the root becomes the numerator, and then the size of the root becomes the denominator. Now in this case, the size of the root is this d, and the power in the root is the n. So n becomes the numerator, and then the size of the root becomes the denominator. For example, if I have the fixed root of x squared, now 5 is the size of the root, becomes the denominator. What about the 2? It becomes the numerator. So this is what it becomes here. Likewise, if I'm converting from exponential, you see now this 4 is going to become the size of the root. What about the numerator? It must be 3. So it becomes like this. Hope we are still together. Let us continue, guys. Hope you are enjoying the lesson. Please take note of that. Okay, now we have operations with the SURDS. The steps for working out SURDS are the following. Number 1, express the SURD in the simplest form, SURD form, and then identify the like terms. Then you can add and subtract. All use the laws of exponents where we have multiplication and division. Okay, note, if you use your calculator, make sure that to show the changes you made, that's say 50 or under root, the same as 25 times 2. So square root of 25, it is 5, then the root 2 remains. So we have examples here. Examples, example 1, simplify square root of 50 plus 2 root 18 minus root 98. Now root of 50, like we saw here, it is 5 root 2. That's why we have it as 5 root 2. What about cube root of 18? Now in this particular case, 18 is the same as 9 times 2, but 9 has got a perfect square root. So in this particular case, the square root of 9 is 3. So the 3 multiply the 3 outside the brackets to give us 9 here. Are we together? To give us 9 there. Then to be under root 2 here, then minus root of 98, okay, which is the same as what? 49 times 2. Now 49 has got a square root which is 7, so it's going to be taken out, then times 2, the 2 remains here. So now I'm left with 5 root 2 plus 9 root 2 minus 7 root 2. So guys, what is 5 plus 9? It is 14. 14 minus 7, I get 7 root 2 as my answer here. Example 2, simplify the fifth root of 81 times fourth root of 27. Now in this case, divide by 5 fifth root of 9 times root 3. So what do I have here? So what I do here, because 81 is I can express it in terms of in the powers of 3. Okay, so for that matter, what's gonna happen? This is 3 power 3, that is for 27. What about 81 in powers of 3? 81 in powers of 3 is the same as 3 to the power 4. Now that 4 multiplied by this 5 here, okay, is going to give us what? Is going to give us, this is 3 power 4 inside brackets here. What about the 27? 3 power 3. Okay, let us get a pen here and work it out properly so that you see what we are really talking about here. Okay, we are saying that 81, this 81 here is the same as 3 power 4. Okay, the same as 3 power 4. So, but there is this fixed root here. So we have 3 power 4 under the root of what? Under the fixed root. Okay, so 3 power 4, and then multiplied by, okay, here we have, what about 27? The same as 3 to the power 3, right? But now we need the fourth root of that. Okay, now we have said that you can express that in exponential notation. Okay, then here over, this is same as 3 squared. That is 3 squared, but under what? The fixed root, which is this is 5 here. Okay, then multiplied by what? Check here, this is root 3. Okay, now note here, the size of the root here is what? The size is 5. What about the power? It is 4. What about the size here? It is 4. What about the power? It is 3. Okay, so it means I'm going to have, actually, I'm going to have 3 on top, 3 to the power 4 over 5. Okay, are we together? 4 over what? 4 over 5. Because we said the size becomes the root, are we together? Then, because it is the same base here, it's going to be now, okay, let me say multiplied by again, multiplied by 3. What is the size of this root here? You can see it is 4. It's going to be now 3 over 4. 3 over 4, power 3 over 4. 3 over 4. And then, because I have the same base here, I'm going to add what? I'm going to add the exponent. So, what is 4 over 5 plus 3 over 4? What is 4 over 5 plus 3 over 4? What do you get? Somebody there? We get 31 over 20. So, it's going to be 3 to the power 31 over 20. So, that's how we got this 3 to the power 31 over 20. Okay, hope we are together, guys. So what you see here is what we have just done here, guys. I think you see that the same thing happens here. Now after getting now the same bases and we are dividing, what we said is subtract the numerators. So it's going to be 31 over 20 minus 9 over 10, which gives us 13 over 20. But we said that the denominator is the size of the root. What about numerator? Becomes the power under the root. So it happens to be our answer here. Hope we are together, guys. Okay, now another example. A rectangle has a length of root 7 plus 1 and a width of root 7 minus 1. Determine the length of the diagonal. Okay, so if you know a rectangle properly, we know that it is like this, right? Our rectangle like this. Now they're saying that we have the length and then the what? The width. Okay. Yes. So if this is my rectangle here, guys, now I want the length of the diagonal here. This diagonal here. Okay. So in this case, I've been given this, I know this 90 degrees, It's 90 degrees here. Okay. So it means I can use Pythagorean theorem, because I know the length, which is root 7 plus 1 here. What about the width? I know root 7 minus 1. So I can say that my diagonal squared or radius squared equals to root 7 plus 1 squared and then plus root 7 minus 1 squared. Are we together? So when I expand on here, I'm going to get 7 plus 2 root 7 then plus 1. What about I'm going to get actually 7 minus root 7 plus 1. Now fortunately, the positive 2 root 7 is going to cancel out with what? With the minus 2 root 7, which you see here. Then I'm left with what? 7 plus 7, that is 14. 14 plus 1, 15, plus another one, that is 16, okay, equals to r squared. So when I find my square, is going to be 4. So my r or diagonal is going to be what? It's going to be 4. Yes, hope we are together, guys. So this is how we apply the exponents, the rows. Let us proceed. Next. Now exponents, let us look at what we call as rationalizing the denominator. Rationalizing the denominator. Now in this case, what is to rationalize the denominator? The process of finding an equivalent fraction that can be expressed without a surd in the denominator is called the rationalizing the denominator. Okay. Now we have got the steps for rationalizing monomial denominators. What do you do in that case? You multiply the numerator and denominator by the denominator's surd and then simplify. And then do what? And then simplify. Example 1, express the following with rational denominators. So this is 3 over root 7 multiplied by root 7 up and down. So when you multiply root 7 times root 7 gives us 7, then it's going to be on top with 3 root 7. Okay, so the answer is what? 3 root 7 over 7. Then if I have it like this, I'm going to multiply up and down by 2 root 3. That's what happens here, by root 3. So now 2 root 3 times root 3, I'm going to be left with the 2 times 3, which gives me a 6. Now this one is going to be distributed in here to give me 6 root 3 and then 3 root 6, which is, that's what you see here, divided by 6 like we said. So now if I check again, I can see that in this case, because this is a 3 and this is 6, which is same as 3 times 2, I can factor out a 3, and that 3 will cancel out with this one of the 3 down here to be left with only 2. That's why my answer is going to be what? It's going to be 2 root 3 plus root 6 over 2. Hope we are together. Example 2. Let's say if x equals root 3 plus 2, simplify x squared plus 2x minus 2 and express the answer with rational denominator. So they give me x squared, but what's my x? It is root 3 plus 2. And when I substitute, I'm going to get squared plus 2. Now expand this gives us what? We say it gives us 3 plus 4 root 3 plus 4, then plus this 2 over this one here. So if you check here, I have 3 plus 4, that is 7, plus 2, which is 9, then plus 4 root 3, then over root 3 down here. So I'm going to rationalize again, multiply by root 3. So now give me 3 in the denominator, like this, and then when I distribute, I'm going to get 9 root 3, and then plus 4 root 3, times root 3, which gives me 3 actually. So I'm going to be having what? I'm going to be having 3 root 3 plus 4. Hope we are still together. Hope we are together. That is how we do what? Rationalize a monomial. Okay. Now sometimes if we want to do binomial denominators, we multiply the numerator and the denominator by the what? By the binomial in the denominator, but with the opposite sign, which we call the conjugate, and then simplify. Why do we do this anyway? Multiplying the binomial by itself will give us a trinomial with an irrational middle term. To avoid this, we multiply the binomial by its conjugate, the same binomial with the opposite sign, to create a difference of 2 squares. For example, here, express the following fractions with rational denominators. Now, this is a binomial down here. So what we do, we are going to change it. We are going to change it and multiply by up and down by, you see this is 5 minus root 7, so it becomes times 5 plus root 7, then over 5 plus root 7, we multiply them. Now if you check down here, I have a difference of 2 squares, right? I have what? A difference of 2 squares, okay? And in this case, because of that, it's going to become simple for me to deal with, okay? So then for that matter, I'm going to distribute this 3 with this one here. It's going to be 3 times 5, which is 15, and then 3 times root 7, which is 3 root 7. Now, because this is the difference of 2 squared, becomes 5 squared minus root 7 squared, which gives me 25 minus 7 over. So I'm going to have my answer as 15, 3 root 7 over 18, okay? So if I check properly, 15 is the same as 3 times 5, so I can take out a 3, then that 3 can cancel out with it, because this is 3 times 6, so the 3's will cancel, left with the 6 down here, and then 5 here, plus root 7. Another example, guys, it's like this. It says that 7 over root x minus 1 over root x. Again, I'm going to multiply by the conjugate. You see, this is root x minus 1 over root x, so it's going to be root x plus 1 over root x, because it was a minus here. Again, multiplied by root x times plus 1 over root x here. So again, you see here, this is a difference of 2 squares again here. So it will be easier for me to simplify. It's going to be actually x minus 1 over x, because whenever I square a square root, I get the term under the root. Hope we are together. Whenever you do what? Whenever you square the square root, you get what? The term which is under the root. Okay. And then I'm going to distribute this 7 with this, what you see here. So it's going to become 7 root x and plus 7 over root x. Then over x minus 1 over x. Okay. Now if I put it under the same denominator here, which is root x, I'm going to have actually 7x plus 7 over root x, then divided by x squared, even here, under x as the denominator, x squared minus 1. So upon simplification here, because it was division, to change it to multiplication, I of course multiply by the reciprocal. Another difference of two squares here is going to be x plus 1 into x minus 1. And then I can cancel this one here with this now. So left with x times 7, which is 7x. Okay. 7x. Then times what? Yes. Okay. Now this one here is root x here. This is just x. So what do I do next from here? I multiply by what? By root x up and down. And when I do so, it simplifies to give me finally 7 root x over x minus 1. Hope we are together. If we are not, please inbox me or come to the tuition center and understand much more. Okay, let us proceed now. Now under exponent and surd, we also recall as factorizing. And please understand here that factorizing is the opposite of distribution, which means that you will subtract the exponents when taking out factors. There are 3 different types of factorization which we're going to look at, which you're supposed to know. Number 1, common factor. Number 1 is what? Common factor. The common factor. Example, factorize the following. If you check here, I have 3x power 5, then y power 4, plus 9x cubed y power 5, then minus 12x squared y power 4. If you check here, this is x power 5, x power 3, x power 2. So the one with the lowest power, the one which is the most common. So there is x squared here, there is x squared here, there is also x squared. That's why we're going to factor it out. And from here, if I take out x squared, I'll be left with what? With x power 3. Now look at the y. This is y power 4, y power 5, and then this is y power 4. So y power 4 is common here, also here, and here. So if I take it out, here I took it out, so I'll be left with nothing there. So I'm not going to be 3. Okay, also the 3 is also common here, and here, and here, which means that if I take out my 3x squared y power 4, I'll be left with only x power 3 here. Then it's going to be what? Because I took out y power 4, I'm now left with y power 1, which is just y. What about here? Everything went outside because 3 times 4 is 12. Then the x squared and y power 4 is what you see here, guys. So that's how we do take out the highest common factor. It could be in fractions, like in this case here. In fractions where I have 4x power 5 over 9y cubed minus 8x cubed over 27y squared, and then plus 16x squared over 3y. Now what is common here, guys? Check here. This is x squared, x power 3, x power 5. We said the one which has got the lowest power is the most common. So this is x squared must be outside brackets. So 4, 8, 16, the common factor is 4, that's what is 4 out here. And then I'm left with x cubed. What about here? 2, and then 4 here. Then check here. This is y squared, y power 3. So the most common here is going to be actually 3y. When I take it out here, I'm going to be left with the 3y squared. What about here? 9y. What about here? Just over 1. So it's going to be plus 4 over 1. So that's also the highest common factor. Hope we are still together. Now another one here is to do with exponential factorizing. What do we do? Similar to common factorizing, like in one, remove the highest common factor first, and in this case a base with its exponents, exponents are subtracted from the same bases. Okay, examples. Factorize the following here. I have 3 power x plus 3, 2 power x plus 3 minus 2 power x plus 1. Now if you check here, now this is 2 power x dot 2 power 3 minus 2 power x dot 2 power 1. Let me show it properly here, so I don't want to lose any of you here. So if you check here, guys, I'm saying that here I have, for this one, the same as writing it as 2 power x, okay, then dot 2 to the power 3, okay, then minus 2 to the power x dot 2 to the power. As you can see that this 2 power x is common, it is common here, also common here, so I can factor it out like this. And when I factor it out, I'm left with 2 power 3, which is here, minus 2, which you see here. That's why I get my answer to be what? What is 8 minus 2? It is 6. Then multiplied by 2 power x. That's my final answer there. Hope we are together. And then another one here, another example here which I have is 2. Example 2, it is 9 power x plus 2, then minus 3 power 2x over 3 power x, then dot what? 2 power 3 times 3 power x dot 5. Okay. Now dot means multiplication here, guys, don't get lost. Now if you check here, my what? If you check here, yes, hello, let us continue. Let us explain this again. We are saying here that 9 to power x plus 2 minus 3 power 2x divided by 3 power x times 3 times 2 power 3 times 3 power x times 5. Okay, the dot means multiplication. Okay, now 9 is the same as 3 squared, and so if we can distribute these 2 outside, that means 2 to multiply the x and the 2 to give us 2 times x, which is 2x, and 2 times 2, which gives us 4. Now if you check here, these are the same bases, which is 3, 3. So it means I can have x plus x, which makes it to be 2x. Okay, and then the 2 squared is 8. 8 times 5, it is 40. Now note something here that you see that there is 3 power to x, 3 power to x, 3 power to x, which means I can factor it out. And when I do factor it out, I'm going to be left with 1 here now. That's the one which you see here. Okay, and then after taking it outside brackets, I'm going to be left with 3 power 4 in this position. That's why it's 3 power 4 here. So I can cancel the 3 power to x, cancel them, and when I do cancel them, I'm left with what? I'll be left with only 3 power 4 minus 1 divided by 40, which gives me what? Which gives me 2, which gives me 80 over 40, which is giving me 2. Hope we are still together, guys. Let us proceed. Let us proceed. We're still looking at factorizing. And then we have what we call as difference of 2 squares. It is very, very common. Very common. This one is applied when there are 2 perfect squares separated by a minus sign. The square root of both terms will be in both pairs of brackets, one with a plus and the other with what? With a minus. Okay. Now note that a perfect square is a term whose number will not leave an irrational solution once square rooted, and whose exponents are divisible by 2. Example, factorize the following. Now check here. If they say factorize on here, we have 9x squared minus 4y squared. By the way, look if there is any highest common factor first before you continue factorizing difference of 2 squares. But in this case, there is none, because this is 9, this is 4, there's no common factor there. Now if you check here, Now 9x squared and then 4y power 6. Now like we said in the method that you have to find the square root of each term. So let's do it here and see what we're talking about here. Now you know what, this 9x squared is actually the same as writing 3. Same as writing what? Same as writing, if I can write 3 open brackets, okay, then I say x, 3x in brackets, then I say squared, okay. Now you see that was the 9x squared, okay, and then now minus, what about the 4y power 6? I can write it as 2, I can say 2, okay, then I say y to the power 3, okay, and then everything squared, okay, everything got squared. So now because this is the same as this, to get my answers to be in the solution, I square root all these terms. I square root to this term here and square root to this term here. So the answer, the square root of 3x squared, you know guys, it's like cancelling the root sign with the square. Likewise here, cancel the root sign with the square here. I'm left with 2x, then minus 2y cubed. So I'm going to have two brackets here with 3x plus 2y cubed and then 3x minus 2y cubed, okay? That's why our answer there becomes like that, okay? So this answer, which is 3x plus 2y cubed into 3x minus 2y cubed, is how we get it, okay? By first of all finding the square roots for each term in the difference of two squares, then we proceed to open two brackets and separate them with a plus and a minus, but still carrying on with the same terms. Hope you're still together. Let us proceed. Let us continue here. Now if you check here, this is x power 4 minus 16, okay, but what do we know? Can write it as x squared squared then minus 4 squared, okay, which is going to give us x squared plus 4 into x squared minus 4. But again, this x squared minus 4 can still continue because it's the same as 2 squared to give us x plus 2 into x minus 1. That's why our answer is what? X squared plus 4 into x plus 2 then x minus 2. Hope we are together, okay. And then our next example here we have x squared minus 7 divided by x plus root 7. Now sometimes you can calculate the difference of two squares as long as the first one has been squared or one of them is squared. In this case, if I know that if I square a root I get that number, it means because of this one is already squared, I can create my own difference of two squares by saying by writing it like this actually. Writing it like this, okay. Let's check it out. You see, I can write it on as x squared, okay, x squared, and then minus root 7, okay, root 7 bracket squared, okay, bracket squared. And now you can see, because I know that this square can cancel the root sign, it will be back at the 7, so it means it is the same thing actually. But because I wanted to create a difference of two squares that I can continue, so I'm going to have the square root of x squared to be x. What about square root of root 7 squared? It's going to be root 7, okay. That's why it's going to be x plus root 7 then x minus root 7 here, then divided by this x plus root 7. So I can now cancel this one here, of course with this, I'm left with x minus root 7. Hope we are together guys, hope we are together. Our next example here, it says that if I have, then this is now x squared plus 2ab plus b squared minus x squared, but we know this one here is a perfect square, it gives us a plus b bracket squared, but then minus x squared. So difference of two squares again, it gives me a plus b plus x, that's what you see here, and then a plus b minus x, that's what you see here as my answer. Now sometimes another method or another way we can be required to do grouping, okay. Grouping, what we do here, we remove the common binomial factor from the expression. Example, factorize the following. Number one, they say x into y minus 4, then plus 3 into y minus 4. As you can see here, guys, that the y minus 4 is a common factor. It is common here and also common here. You see that? So in that case, what is common here as well, it means I can take it outside the brackets. And when I do take it outside, I'm going to be left with x plus 3. That's why my answer is going to be y minus 4 into x plus 3 as my final answer. Hope you're together. Now another one here is a squared plus 2ab plus b squared minus 3a minus 3b. Now again, as you can see here, this is a perfect square, like we said before, which is the same as saying what? A plus b bracket squared minus 3 into a plus b. Now here I took out minus 3. If you check here, I've got a plus b, it is common here and also common here, guys. It's also common here. So for that matter, if I take out a plus b, I'm left with a plus, because these are two of them, because this is a plus b times a plus b, right? That's why if I take out one, I'm left with one a plus b, and then guess what? Then this minus 3 comes here. Hope we are together. Let us proceed. Let us proceed. Next we have what we call as here we have 5x minus 15y plus 9ay minus 3ax. So now this time check here. What is common here, guys? It is 5 left with x minus 3y. And what is common here? It is 3a. 3a left with 3y minus x. Okay. Now note here that this is x minus 3y. Do you not see that? X minus 3y. What about here? This is 3y minus x. But before I take out a common factor, I can see that to make these two the same, what do? I take out a negative 1 here. If I take out a negative 1 here, it's going to be that negative 1 times positive to make it negative, which means that now in the brackets, instead of having 3y minus x, now I have x minus 3y. Why? Because a negative 1 times x gives me back a negative x, and a negative 1 times negative 3y gives me back a positive 3y, which means it is correct. Okay. Now that I have the same factor, which is x minus 3y here as well as here, it means now I can factor it out. That's why it's outside like this. And then left with what? Left with this 5. Then minus what? Minus 3a. That's why it is 5 minus 3a. That's my answer here. So it is x minus 3y into brackets 5 minus 3a. Hope you understand. Let us continue. Let us proceed. That is calling grouping. Okay, let us proceed. Now, sometimes you're going to be required to use sum or difference of two cubes. Sum or difference of two cubes. It is applied when there are two perfect cubes separated by a plus or minus. The final answer will be a binomial in the one bracket and a trinomial in the other bracket. Now, a perfect cube is a term whose number will not leave an irrational solution once cube rooted and whose exponents are divisible by 3. Example, factorize the following. X cubed minus 8. Now 8 is the same as 2 cubed. So here it means like we are factorizing difference of 2 cubes, because this is x cubed minus 8. We're saying 8 is the same as what? 8 is the same as 2 cubed. So it's actually it's like I have something like this. I have x cubed, okay? I have x cubed, okay? And then minus what? Minus 2 cubed, because 2 cubed is 8. So now note something here. The first bracket is going to have the same sign, which is x minus 2. That's x minus 2 here. You see this x and this, that's x minus 2 here. And then the next bracket is going to have x squared, which is here. Then plus the product of these two here, that's plus 2x. And then plus the last one squared, which is plus 4 here. That's my answer there. We are still together. We saw this also in grade 11, if you remember. Okay, that's called difference of two cubes. Then it could be a sum of two cubes. In this case, this is 27x power 6 and then plus 64y power 9. Now if you check here, I can write down properly as sum of two cubes like this by writing 3x, by writing what? 3x squared, okay? 3x squared, and then to the power 3, okay? And then now plus 4y cubed, again to the power what? To the power 3, okay? Why? Because 3 to the power 3 is 27, which you see here. Then x squared power 3 is the same as x power 6. And then 4 to the power 3 is the 64. And then y cubed is the y power 9. So it's the same thing. Now, because I've got a sum of two cubes, I proceed by using that formula for the sum of two cubes, whereby you take the one in brackets with the same form operation here. That's a plus, going to be 3x squared plus 4y cubed. That's why you see it here. And then into this first term squared, which is giving us 9x power 4. Then now minus the product of the two terms. That's why it's going to be 3 times 4 is 12 here. And then x squared times y cubed gives us x squared y cubed. Then plus the last term squared, which gives us 16y to the power 6. Let us continue with the trinomials as well here. Now with trinomials, the ratio of exponents of the term 1 to term 2 is 2 to 1. A combination of vectors of term 1 and term 2 must give you term 2. Okay? If you combine the factors of the first term and the second term, must get the term 2. Okay, let us see how to factorize this. And now they say factorize, and they give us 3x squared minus 5x minus 2. Okay, so because I'm going to have two brackets here, and the first term here is 3x squared, it means that if I've got my 3x here, I must put x, because 3x times x must give me what? 3x squared. Okay, and because this is negative 2 here, it means that for me to have a negative 2 at the end of my constant, this should be 3x plus 1 with a negative 2, because positive 1 times negative 2 will give me what? Will give me negative 2 here. But not something else, that if I multiply 3x times negative 2, I'm going to get negative 6. What about 1 times x? I'm going to get positive x. So the negative 6 plus x gives me minus 5x, which is the middle term. Hope you see that as well. Another one here, we have x squared plus 3x minus 10. I'm going to have two brackets again. Then I use the factors of minus 10. Okay, when I add them, I get positive 3, but when I multiply them, I get negative 10. Check here, those factors are positive 5 and negative 2, because positive 5 times negative 2 gives me negative 10, and positive 5 plus negative 2 gives me positive 3. So that's why my answer is going to be x plus 5 into x minus 2. Hope we are still together. Another example here is x squared plus 3x squared minus 10. Now in this case, I'm going to look for two numbers, again two factors, multiply, get negative 10. When I add, get positive 3, so they're going to be, now this is x power 4, this is 3x squared, but this is a constant here. So I'm going to have x squared times x squared here, and then now I'm going to have positive 5 and minus 2 still, because positive 5 plus 2 gives me positive 3 here, and positive 5 times negative 2 gives me negative 10 here. Hope we are together. And then number 4, I have x power 2 over 3 plus 3x power 3 minus 10. Now in this particular case, I'm going to have x power a third into bracket, then plus x power 3 into bracket. Because this is a minus, I'm going to have two different signs in the bracket. I'm going to have a plus and a minus, okay? But not something that here, in this particular case, my middle term is positive 3. What about the constant? Negative 10. So note that if I multiply x power a third times x power a third, I get x power 2/3. I don't know if you see that, or must I show it to you? I'm saying if I multiply x power a third times x power a third, I get x power 2/3. You can say, how does it come about? It comes about like this. Check this, guys. If I multiply x power a third, okay, x power a third x power a third, okay, multiplied by x power a third again. Now because I have the same base, it means I'm going to add what? I'm going to add the exponent. So what is a third plus a third? Don't you get 2/3? That's what you get. So that's why we are using here x power third and x power third here. Hope we are together to split that trinomial. Okay. Another example, which is example number 5, we have 5 power 2x plus 3 dot 5 power x minus 10. Now in this case, again, this 5 power 2x, it came from multiplying 5 power x times 5 power x, and then you see I'm going to have again plus 5 then minus 2 here. So this is another way of doing factorizing here. And then lastly we have 3 power 2x then plus 3 power x plus 1 minus 10. Now in this case, if you check here, this 3 power 2x is the same as saying 3 power x into times 3 power x. Are we together? So again, if you check here, I still have positive 3. So I still have the same factors of positive 5 and negative 2. Hope we are together. If you're not together, please don't hesitate. You can inbox me on 0785222041, or you may come to our tuition center here in town, Rostec College. Okay, now still in question 1, we have what we call as equations. Now these equations, they include the following equations. They can be linear equations, and if they are linear equations, in that case what do we do, teacher? You move all the variables, okay, to one side and the constants to the other side, then solve. So the linear equations only have one solution. For example, solve 3 into x minus 2 plus 5 equals to 5 minus x plus 9. Open brackets, 3 times x minus, it's going to be 3x, 3 times minus 2 minus 6, and then minus 1 times x minus x, then minus 1 times positive 9 minus 9. So correct like terms, the minus x becomes a positive here this side. What is 3x plus x becomes 4x, and then here I have minus 6 plus 10, which is positive 4, but that positive 4 becomes minus, so 5 minus 9 is minus 4. So I'm going to have minus 4, then this minus 4 there minus the other 4, I get minus 8, which gives me, if I divide by 4x, I'm going to get negative 2 as my answer. So that's linear. Now this one here, when I open brackets here, as you can see, I'm going to get x squared minus 4x plus 4. What about side x times x gives me x squared? This is the difference of two squares, so it gives me x squared minus 9. So the x squares cancel, leaving it linear. Now this positive 3 becomes a minus, so I have minus 4x equals to minus 12. So divided by minus 4, both sides gives me what? Gives me positive 3. That is to do with linear equations which have got only one solution. Let us look at quadratic equations. Now what do you do here? You move everything to one side and equate to 0 by factorizing the trinomial. You should find the two solutions. For example, solve for x. Here we have x squared plus 5 equals to 6x. Now before we proceed, this 6x must come this side to leave a 0 this side. You see it was positive, it becomes minus 6x. Then factorize like we did in the previous worksheet. So two numbers multiply get positive 5. When we get negative 6, that's negative 5 and negative 1, which gives us either x equals to 5 or x equals to 1. Hope we are together. Then if they give us like this, so please, because this is 0, don't even disturb yourself. Just say either 3x minus 4 equals to 0, which gives x equals to 4 over 3, or 5x plus 2 equals to 0, which gives us x equals to minus 2 over 5, using the 0 factor law. Okay, let us continue here. Now another example here, example 3, it says x power 4 plus 3x squared minus 10 equals to 0. We finished this one factorizing already. Now after equating 0, we see that either x squared equals to minus 5 or x squared equals to 10, but this one, because it's negative here, it won't give us real solution. Why? Because we said square root of a negative has no real solutions. Then all x squared equals to 2, which gives us what? Plus or minus 2. Hope we are together. Then this one here also, we already finished factorizing. So after equating to 0 here, then you do what? You say either x power a third equals to minus 5 or x power a third equals to 2. Then you find what? You cube both sides to get x equals to negative 125. What about here? It gives x equals to 8. Gives x equals to 8. Hope we are together. Yes, hello. Number 5, example 5. Now, this is we already done factorizing this as well. So after equating to 0, we say either x power a half equals to minus, this is positive, right? It becomes minus 5, or x power half equals positive 2. Now, because this is negative here, still it won't be what? It won't be applicable. But for the 2, we are going to have it because we just square both sides. We just square both sides here. Okay, and then then from here, let me check this. I'm saying that when we reach here, we have x power a half plus 5 into x power half minus 2 equals to 0. So either this bracket, that is x power half equals to minus 5, or x power half equals to 2. So what do we do in that case? We can square both sides, to remove the root sign. We do what? Square both sides. And when we do square both sides, what do we have? We're going to have something like this now. If I square both sides, I'm going to have power half means square root, but now I'm squaring both sides. If I do square both sides here and here as well, now this is square, we cancel with the root sign. Okay, what's negative 5 squared? It's going to give me 25. So x will be what? X will be equal to 25. Okay, and then this side, I'm going to have, if I square 2, I'm going to get what? I'm going to get 4. So if I square both sides, I'm going to get here what? I'm going to get x equals to 4. That's as we have x equals 25 or x equals to 4. Hope we are still together. Let us proceed. Let us proceed here. Now when I get here, I have 6, I have some already factorized. We have 2 power 2x minus 6, then 2 power x minus 6 equals to 0. Factors, 2 numbers multiply, get minus 16, I get negative 6. I have positive 2 and minus 8. Okay, and then what happens? I say either this bracket equals to 0, which gives me 2 power minus x equals to 2, or this bracket which gives me 2 power x equals to 8. But because this is negative 2 and this is exponent, so it's not applicable. That's why it's not applicable here. But for this case, x is the same as 2 power 3, which means if I drop the bases, what's my answer? It's going to be x equals to 3. Hope we are still together. Let us proceed. Let us proceed. Now another example is called simultaneous equations. Now here, solve for the 2 unknowns in 2 different equations using the substitution method. Remember to solve the both unknowns by substituting them back into the original equation. Example, we have got this equation here. Equation 1, 2x plus 3y equals to 18, and then minus 3x plus 5y equals to 11. So here, if you check here, I can say from the first equation that 2x equals to minus 3y plus 18. If I divide by it, I'm going to have what? I'm going to have minus 3y plus 18 divided by 2. Then I call it my first equation here. I give it equation 1a. Now, if I do substitute, because you see that in this case, my x which you see here, guys, this x, this x is equal to what? Is equal to minus 3y plus 18 over 2. Is the same x which is in the second equation. where I have minus 3x plus 5y equals to 11, which means I'm going to, where I have this x, I'm going to put what? I'm going to put minus 3y plus 18 over 2. That's what I do exactly in the next equation. So I have minus 3 into minus 3y plus 18 over 2, then plus 5y equals to 11, open brackets, negative 3 times negative 3, I get positive 9y here. What about minus 3 times positive 18? I get minus 54, then over 2 plus 5y equals to 11. And when I simplify this, I'm going to have I'm going to have one variable now in terms of y, which I can easily solve to get my what? My y. In this case, 19y equals 76 divided by 19 gives me y equals to 4. After getting y as 4, I go back to my first equation to get the value of x by putting 4 here, which gives me finally x equals to what? X equals to 3. Hope you're together, but sometimes, especially grade 12, we can have one linear, one quadratic. Like this is linear, this is quadratic. So what do? From the one which is linear, we make either x or y the subject of the formula, and we have you see this is positive 3x becomes minus 3. It's going to be y equals to minus 3 plus 2. Now this y which you see here is the same y which appears in the quadratic equation now. So I'm going to substitute where I have y, you see in this one which is quadratic now, where I have this y, I'm going to actually put what? I'm going to put now this minus 3x plus 2. That's what happens here. So it's going to be minus 3x plus 2 bracket squared, then minus 9x squared equals to 16. I expand on as usual to give me 9x squared minus 12x, then plus 4, then minus this 9x squared equals to 16. So the 9x squares, they cancel, then minus 12, then the 16 minus 4, it is 12, so divided by minus 12 gives me x as negative 1. After getting negative 1, I come back to get the value of y in the linear equation, and to do so, I substitute. I know that my y plus 3 into, now my x is negative 1 equals to 2. So 3 times minus 1 gives me minus 3. Then plus 2 gives me 5. So y equals to 5. Then that's my solution, which is minus 1 is to 5. Hope we are together. Don't forget the logic here. You make for the linear equation, you make one of them the subject, then substitute in the quadratic equation. Hope we are together. Then sometimes you have to call as the SURD equations. Now in this particular case, you isolate the SURD on one side of the equation, power both sides of the equation by the root, then ensure that you check your solutions by substituting your answers back into the original equation. Okay, I repeat, this is the method here. We said that you do what? First of all, you isolate the SURD on one side of the equation. Then afterwards you do what? After that you power both sides. Of the equation by the root. Okay, by the root. Then, but you must ensure that you check your solutions by substituting your answers back into the original equation to prove that you are right. Now here, this one is already on one side of the equation, the square root. So here we just square both sides. If I square here, I'm going to cancel the square with the root sign. It will be left with x minus 2. And the square of 3 is 9, which gives me x equals to 9 plus 2, which is 11. Here, this one was simple. And then you check here now. If you check in this case, now I have this one now. You see this is minus x here. So before I square both sides, before I power both sides, I must bring this minus x this side to make it 3 plus x. Don't forget that, please. Okay. Now I can find the square on both sides because now I have only the root this side. Okay. So if I do so, guys, as you can see, I'm going to square both sides. Make this. I square this side. Okay. Also this side here. Also do the square. Now this square cancels the root sign here, and I'm left with what? With x plus 5. No, square this one gives me x squared plus 6, x plus 9, and then I'm going to have 0 equals to x squared plus 6x plus 9 minus 5, which gives me plus 4. So, but I can factorize it on here, fortunately. Then I get either x plus 1 is 0, which gives x equals to negative 1, or x plus 4, which gives x equals to what? To negative 4. But I must remember that if my x is negative 4, what's going to happen to my root? Let's go back and check here. If I put negative 4 here, what is negative 4 plus 5, guys? It gives us what? It gives us positive 1. Altogether, we're saying that if you check our solution with negative 4, let's check it properly. So we have our x is negative 4, for example, from here, negative 4, and then plus 5, plus 5, okay, and then minus, what's our x? Negative 4, okay, must give us 3, let's check it out. So if you check a negative 4 plus 5 gives me 1, square root of 1 is 1 here, altogether, then minus 4 gives us positive 4. So if you check here, 1 plus 4 does not equal to 3, because this is 5 and this is 3, so which means that negative 4 is not one of the answers. The answer is negative 1. Let's check it out. With negative 1, with negative 1, it gives us the right answer. Let's check it out. Let's check it out here. We have square root, okay. Now negative 1 plus 4, plus 5 is positive 4. Square root of 4 is 2. Square root of 4 is 2. And then minus, what's our x? We say it's negative 1, okay. And then it should give us what? It should give us 3. So what's square root of 4? It is 2. 2. Then 2 plus 1. As you can see, 3 gives us 3, which means we only have this answer, which is negative 1. That's why the other one was what? Was left out. Hope we are still together, guys. So don't forget to check your answers before you submit your answer sheet, okay? That's to do with when you're solving the SURD equations. Now another type is exponential equations. Here you make sure that you get a term on one side of the equation that has a base that is equal to the base with the unknown exponent, then drop the bases, then equate the exponent and solve. I repeat, we are saying that in this case, what do you do? First of all, make sure that you get a term on the one side of the equation, okay, that has a base that is equal to the base with the unknown exponent. They must have the same base, in other words, as the unknown exponent. Then drop the bases and equate what? And equate the exponents and then solve, okay? And then solve. We have some hints here. Never drop the base if the terms are separated by plus or minus. What do you do then? You remove the common factors until the equation is in its simplest form and then solve. Always convert decimals to fractions and then to bases with negative exponents, okay? Let's look at examples here. Solve for x, that is 4 power x equals to 8. Now you see this is 8 here and this is 4. 4 is the same as 2 squared. The square times x, it makes 2 power 2x. What about x? Is the same, 8 is the same as 2 power 3. So because I have the same base now, I can drop the base and then I equate the 2x equals to 3. So x equals to 3 over 2. What about here? This is equal to 64. But if I look at my calculator, it's the same as saying 1 over 16 to the power x equals to 2 power 6, that is 64. But what is 16, guys? The same as 2 power 4. So if I take it in the numerator, I'm going to have 2 power negative 4x equals 2 power 6. Now because I have the same bases, I can drop them. Then I take the exponents at negative 4x equals to 6. I divide by negative 4 to give me x equals to negative 3 over 2. Hope we are together. Let us proceed here. Now here I have 2 times 3 power x plus 1, then plus 5 times 3 power x equals to 33. Now here, before I continue, because this is a plus here, I can take out what is common here, that is 3 power x. It is common, I'll be left with 2 times 3 power 1, then plus 5 here equals 33. So 2 times 3 is 6, plus 5 is 11. So divided by 11 both sides, I get 3 this side to power 1. I drop the bases, equate the exponent, which gives me x equals to 3. Hope we are together. Then next example here, I have 27 power 3x plus 1 equals to 81 power 2x plus 5. So what is happening now? I can say this is same as 3 cubed, then power this one here. What about here? 3 power 4 power this. When I distribute this on outside the brackets, I'm going to get 3 times 3x gives me 9x plus what? 3 times 1 is going to be 3 here. Then 4 times 2x gives me 8x. Then 4 times 5 gives me 20. So that I have the same basis, now I can drop them and get my x as 17 after solving for x. Now here I have this now. I have 0.5 power x dot root of 1 plus 9 over 16 equals to 10. I first simplify the square root here, which gives me 25 over 16, which is the same as 5 over 4. So what do? This is a half, then the same as 2 power minus 1, but minus 1 times x becomes minus x. Then I have 5 over 4 equals to 10. So what do? Multiply by 4, divide by 5, which gives me 8. Okay, but what is 8? The same as 2 power 3. And because I have the same base, which is 2, then I do what? I drop the bases and equate the exponents, which gives me x equals to minus 3 as my final answer. Hope we are still together. Now this is going to be in our next video, that is for question 2. Thank you so much for watching. Please try out these questions now. Try out these questions here to see if you understand what we're talking about. Now you can complete this question, which was asked in May, June. That is May, June. It was 2021. Please work it out to see if you understand it. It goes like this. Okay, finish it now before you go to question 2. I'm sure after watching the video you can do this question properly now. Then after that, also try out this one now. Try out this, which is from November 2020. Question 1. It goes like this. Please, you can now finish it up after watching the second video here. Okay, so please solve it. In case of any challenges, you can inbox me on O785222041, or you can come at Rostec College on 92 Schoolman for more information. And then lastly, you can also try this question here, which was November 2021, that is last year. Question 1 here. I'm sure you'll pass it as well. Okay, if you find any challenges, yes, why not? You can inbox me or come to our center at 92 Schoolman Rostec College in town here of Polokwane. Thank you so much for watching. Catch you again in my next video.